First of all, let me give you a brief introduction of what Monte Hall problem is all about. In Monte Hall problem, we have 3 doors. 2 of them comprise of goods and 1 of them comprises of a price, say BMW. In this whole programming screencast, we'll be using BMW as the price. So in Monte Hall problem, participant is asked to choose any one of these doors. After he or she has made his or her choice, the host asks the participant to change his choice. What the host basically does here is he opens a particular door out of these 3 doors. Okay, now we are left with only 2 doors, one that has been chosen by the participant and one that hasn't been opened yet. So now the host asks the participant to change his choice. It depends on the participant to swap or not to swap his or her choice. Now, what the participant should do here? Should he swap or not swap? This is the question that we should answer. Okay, so this is the question we'll be exploring, we'll be answering in this programming screencast. We'll have a kind of setup here in which we have 3 doors, 2 of them comprise of goods and 1 of them comprises of BMW. After the choice whether the participant has swapped or not swapped, we'll try to explore this fact that what is the optimal strategy here, whether the participant should swap or not swap. Let us try to explore this fact. So let us start with the programming screencast of Monte Hall. As I said, we need 3 doors here, so I'll be taking a list here named doors. Okay, so this is a list doors. I'll be taking another list here called goat door that will keep a track of the doors that comprise of goats. After that, I'll be taking 2 variables, swap and don't swap. This will take care of the fact of number of swap wins and number of don't swap wins. Swap will basically keep a track of number of swap wins. I'll just write here number of swap wins, and don't swap will keep a track of number of don't swap wins. Don't swap wins. Okay, now that we are done with it, we'll generate a random number here that will keep a track of what particular door will comprise of BMW. So since we are only given 3 doors here, we'll call them 0th door, 1st door and 2nd door. So we have to generate a random number here, random.randint from 0 to 2. Okay, so either any of these 3 doors will comprise of BMW. So I'll just write here x will comprise xth door will comprise of BMW. Okay, now that we are done with it, after that I'll just write doors x will comprise of BMW. Yes, we're done with it now. Now the rest of the doors should comprise of goods. So I'll just do that here. For I in range, just write 0 to 3, since this will take into account the indices 0, 1 and 2. So if I here is equal to x, then you continue. Okay, continue. What does continue do here? What purpose does it serve here? If I write continue, then it will go to the start of the loop. Okay, if I write continue, it will go to the start of the loop. Since the xth door already comprises of BMW, we only need to take into account the doors except x. So if I is equal to x here, it will again go to the start of loop and increment I. Because we are not considering x here, we are only considering the doors that comprise of goats. Else what we are going to do here, else we'll just see doors of I, it will comprise of goat. So you just write goat here. One thing we have to do here, we have to append goat door also here, goat door dot append and particular index, and that is I here. So we are done with the doors. Two of them comprise of goat and one of them comprises of BMW. After that we have to make the user input its choice. So let us do that. Choice is equal to int enter your choice. After that, int input. You just write int input, that will make the user input his or her choice. Now we have to, now that user has made his choice, now the host will ask the user about swap or not to swap, but before that he will open a door. So door open, we'll take a variable here, door open. I'll again generate it randomly here, so I'll write random dot choice goat door. Now please note this fact that we can only open the door that comprises of a goat. We can only open the door that comprises of a goat, so we are only considering goat door here. I hope that you are familiar with random dot choice. We have already explained it. So goat door is a list here from which a choice from which door will be taken randomly. So here we have to open a door that only comprises of goat. So I'll write here open a door that comprises of goat. Okay, now that we have opened the door, after that what we have to do here is we also need to take care of this fact in mind that the choice and the door open shouldn't be same here. For example, if the participant has made a choice of a door that comprises of a goat and we are also opening that particular door, please note the fact this is not allowed here. So we need to also take care of this fact that the choice and the door open shouldn't be same. So I'll just have a while loop here. While door open is equal to choice, I'll again and again choose it randomly from the list goat door. So I'll just write door open is equal to random dot choice goat door. So you just need to write here, I'll just write a comment here, door open shouldn't be equal to choice made by the participant. Okay, So we have also done that. After that, we have to give a choice to the user whether he or she wants to swap or not. So you just write swap int input. We don't need to write int here. You just write input. Do you want to swap? He or she will answer in Y or no, in Y or N. Okay, so done that. After that, you have to apply a if loop here. So just write if ch, if the choice made by the participant is yes, then it will be Y. Then what you have to do here is, if doors choice is equal to goat, that means he made a choice of a door that comprised of goat at initial stage, then he'll win here. Print player wins. Okay, and you have to increment the swap variable here. Else what you have to do is else print player lost. I'll again explain the if else loop here. What we are doing here is, if ch is equal to y, that means the player has chosen to swap. If he has chosen to swap, then we have to take care of this fact that if he has chosen goat in its initial state, in its initial choice, then if he swaps here, then obviously he'll get a BMW here, because already a door comprising of goat has been opened, and a door that has goat he has chosen in its initial stage, and now he is swapping. Now if he'll swap, then he'll get BMW. Okay, so he is winning through swap, so we'll increment the swap variable here. Else if he has chosen BMW at his first place and now he is swapping, obviously he is going to lose this game. So now we are done with if ch is equal to y, and if he doesn't choose to swap here, what we'll do here? If he doesn't choose to swap here, we'll write if doors choice is equal to goat. If his choice was goat initially, then and he doesn't choose to swap too, then he is bound to lose the game. So you just write print player lost. Done. Else if he didn't choose goat at his first place, then he will win because he has chosen BMW in his initial choice. You just write print player wins. Okay, and now he has won because he hasn't swapped, so you have to increment the don't swap variable here. So just increment don't swap is equal to don't swap plus 1. After that you have to print the number of swap and don't swap wins. So let us try to run this program. So just save it, Monte Hall .py. Sorry. So let us try to run this program again. There is some error here. I'll just show you. It is saying random is not defined because we haven't imported the library random. So you just write import random. List index out of range. It is giving us an error, list index out of range. So how can we handle that? Let me think about it. We can easily handle that. I think we need to initialize the list here. You just initialize it with 0. Okay, since we are only using 3 doors here, multiply it with by 3. Also initialize this particular list here, that is code door. So you write 0 here and multiply it with by 2. So again run it. Name door is not defined. So it is basically doors, not door. Let me check if I have used it in some other place. No. So let us try to run it again. Enter your choice. So you have to enter your choice from of your door choice. So it can be 0, 1 or 2. So I'll enter 0. Do you want to swap? I'll choose to swap. So player wins. Okay. Now the player has won because he has swapped. Okay. Again I'll run it. Enter your choice. I'll enter 2 here. Do you want to swap? No. Player wins also here. So again run. Enter your choice. I'll enter 2. Do you want to swap? Yes, I want to swap. The player lost because he or she swapped. Again run. 1. Do you want to swap? Yes. The player wins. Again enter your choice. 2. No. The player lost. So how can we keep a track of this? How can we find out that what is the optimal strategy here? I'm really confused. So what I will do here is I'll run this program again and again, for example 10 times, and then try to find out what are the number of swap wins and number of don't swap wins here. So for that I'll just take a variable here. So I'll just take a variable. For example, I took j is equal to 0, and I'll have a while loop here while j is less than say 10. I'll run it 10 times. For that you have to indent it properly. So indent it properly. So since we have to run it 10 times, I'll just use a while loop here. For that you have to indent it properly. Okay, so now this has to go here, this has to go here, this here. Now it has to be inside the while loop. After that the choice thing would also be inside the loop. So you just write choice here. This if loop was inside this if loop. So this is nested basically. This else is for the above if. Please indent it properly, I'll request you, otherwise you will get an error. After that this else is for the above if. Okay, now that we are done with it, so let us try to run it. Enter your choice 0. Do you want to swap? Yes. Enter your choice 2. Do you want to swap? Yes. Enter your choice 1. Do you want to swap? No. 2. Swap? Yes. 1. Swap? Yes. So it is going on and on. I think I didn't I think we didn't increment the j variable here. Yes, you need to increment the j variable here, so just write j is equal to j plus 1 so that it runs for a definite number of times. Okay, so I'll just do that. Okay, we have exited. Now let us try to run it again so that we can get what is the optimal strategy here. Enter your choice 0. Do you want to swap? Yes. Player wins. Do you want to swap? No. Do you want enter your choice 2? Do you want to swap? Yes. 1. Do you want to swap? No. 0. Do you want to swap? Yes. Enter your choice 2. Do you want to swap? No. Enter your choice 2. Do you want to swap? Yes. Enter your choice 1. Do you want to swap? Yes. Enter your choice 1. Do you want to swap? Yes. Enter your choice 0. Do you want to swap? Yes. So here number of swap wins, as you can see, is 5 and number of don't swap wins is 1. So is swapping is the optimal strategy here? Do you really think so? Is swapping the optimal strategy here? Let us try to run this once again and try to find out what is the optimal strategy. So let us try to do that again here. 0. Do you want to swap? Yes. 1. No. 2. Do you want to swap? No. 1. No. 2. Yes. 0. Yes. 2. Yes. 1. No. 0. No. 1. Yes. So here also number of swap wins are greater than number of don't swap wins. So I'll run it once again so as to get a clear-cut idea of what is happening here. So enter your choice 0. Do you want to swap? Yes. Player lost. 1. Do you want to swap? Yes. 2. Do you want to swap? Yes. 1. Do you want to swap? Yes. 2. Do you want to swap? Yes. Enter your choice 1. Do you want to swap? Yes. 0. Do you want to swap? No. 2. No. 1. No. 0. No. So number of swap and number of don't swap wins are equal here. So we are getting different distribution, but in every case that we have run here, number of swap wins are either greater than number of don't swap wins or they are equal to number of don't swap wins. So we can say that we are not sure of this fact that we'll always win if we swap, but there is higher probability of you winning if you swap. Yes, this seems right from the program that we are doing here. Number of swap wins are always greater than equal to number of don't swap wins. So we can say that there is higher probability of you winning if you swap, and there is lower probability of you winning if you don't swap. So now that we are done with the program, we'll just go through the program once again. So what we are doing here is, first of all, you have to make two lists. First one is doors and second one is goat door. We are taking only 3 doors here: 0th door, first door and second door, and we have 2 goat door here. 2 of them comprise of goats and 1 of them comprises of BMW. Next, what we are doing here is we are taking the track of number of swap wins and number of don't swap wins through these variables. After that, we'll have a while loop. Why we are using a while loop here? Because we need to keep a track of number of swap and number of don't swap win. Okay, so I am running this program 10 times. You can run it 50 times, 100 times and check what is the optimal strategy. According to me, it is number of swap wins. It is the swapping strategy, and it will work in your case too. Please check it. After that, I am taking a variable x here. This particular door, exit door, will comprise of BMW. Then we are using a for loop here, because the rest of the doors would comprise of quotes. Exit door comprises of BMW and rest of the doors comprise of quote. Now what we are doing here is we are using a new keyword here, continue. Why I am using here? Because exit door already comprises of BMW, and if I is equal to x here, then we have to continue. We have to bring the control of the program to the start of the loop, because we are not considering x here, we are considering rest of the doors here. And else if I is not equal to x, then doors at I will comprise of goat. I also need to append in goat door list, because that is keeping a track of doors that comprise of goats. After that, you have to enter your choice. Okay, the choice the participant that chooses. After that, door open. Now the host will open one of the doors. Okay, please note this fact in mind: the open door and the choice shouldn't be equal. Okay, they shouldn't be equal. So we are using a while loop here. So door open is equal to random.choice goat door. Since we are already using a goat door list here, I'll just make a choice from the list goat door. Okay, after that you have to make the user input whether he or she wants to swap or not. Okay, so you just ask the user, do you want to swap y or n? If ch is equal to y, then if ch is equal to y, that means he or she wants to swap, and he has made a choice of goat at first place. And if he has made a choice of goat at first place and now he is choosing to swap, then he is bound to win. Now he will get a BMW. So in this particular case, the player wins, and he has won because he has chosen to swap. So we'll increment number of swap wins, else he'll lose the game. After that, if he doesn't choose to swap and he has chosen goat in his initial choice, then he is bound to lose the game. Else if he has chosen BMW and he is not interested to swap, that means he is going to win the game. In this particular case, number of don't swap wins will be incremented. Now since we are using while j less than 10, we are using j variable here, we need to increment j here. So we incremented j here. After that, we are printing number of swap wins and number of don't swap wins. I hope you understood this particular program on Monte Hall, and this programming screencast was useful to you guys. Thank you. Happy learning.